Hello, my name is Cecilia. I'll be presenting a question out of the 15-16 Semester 1 paper, question 3A3. For this question, we need to find the probability that at least 3 out of 5 selected customers will have a waiting time of more than 5 minutes waiting for their food. So for this first step, we'll let X be customers' waiting time in minutes. The question already gives us that the mean waiting time is of 4 minutes and the standard deviation is of 1.2 minutes. So we'll firstly insert this into the probability formula, x minus mean over standard deviation, and find the probability that customers in general will wait for more than 5 minutes. That will be 5 minus 4 over 1.2, which will give us the result that it is 0.83 standard deviation above the mean. We'll then look on our standard normal table and find that means the probability of customers waiting for more than 5 minutes is 0.2033. Now the next step of solving this problem is finding the probability of at least 3 customers waiting for more than 5 minutes, 3 out of 5 customers. So in order for us to do that, we'll find the probability of 3 customers, 4 customers, 5 customers waiting for more than 5 minutes and add them all up. We'll do that by inserting the numbers into the binomial distribution formula, where n is going to be 5 due to the fact we want for them to wait for more than 5 minutes. X is going to be each number of customers we want to find for. P is a probability we just found, and Q is going to be 1 minus the probability we just found. So we will do that for each of the numbers. And we will round every answer down to 4 decimal points. And that will give us the result, which is 0.0605. And this is the probability that at least 3 out of 5 randomly selected customers will be waiting for more than 5 minutes.
I'm and I'm responsible for 15-16 Semester 1 past paper question 3B. The question is that 0.01% of people will be affected by certain infectious disease after vaccination. Among all people having vaccination, 500,000 people are selected at random. Calculate the probability that 51 or 52 people will be affected by the infectious disease. To solve this question, we first let X be the event that people will be affected by the infectious disease. So the sample size should be 500,000 and the probability should be 0.01%. Then we take this information to the binomial distribution. However, the sample size is very large, so it's difficult to implement the normal distribution. Since the number of trails n gets very large, and p, the probability of success is small. So Poisson approximation to binomial distribution can be applied in this case. By applying Poisson approximation, lambda equals to n times p, which is 500,000 times 0.01%, which is 50. So we can implement the Poisson distribution with the mean of 50. Then we can calculate the probability that 51 or 52 people will be affected by the infectious disease, which is the probability that x equal to 51 plus probability that x equal to 52. Then finally we get the answer that is 0.1083. By applying Poisson approximation, lambda equals to n times p, which is 500,000 times 0.01%, which is lambda equals to 50. Then we implement the Poisson distribution with the mean of 50. Therefore, the probability that 51 or 52 people will be affected by the infectious disease is that the probability that x equal to 51 plus probability that x equal to 52. We then simplify the calculation of Poisson distribution, that is, e to the power of negative 50 times 50 to the power of 51 over the factorial of 51 plus 50 to the power of 52 over the factorial of 52. And finally, we get the answer that is 0.1083.
Hi, I'm Sonia, and I'm taking part of question 4A from 2015 to 2016 semester 1 past paper. In question 4A1, there are 80 customers are invited and 64 of them commented that the level of sweet is acceptable. It also construct a 95% confident interval for the population proportion. Let P be the population proportion of customers who accept the level of sweet. In this experiment, we know that the sample size is xt and 64 of them accept the level of sweet. Therefore, n equal to 80. Then P equal to 64 over 80 equal to 0.8. And 1 minus P equal to 1 minus 0.x equal to 0.2. Then we can apply the general formula of the confidence intervals, which is shown here, where Q is 1 minus P equal to 0.2, and as we are finding 95% confidence interval, alpha over 2 will be 0.025, and through T distribution table, we know that Z equal to 1.96. Then after calculating, we know that the minimum value will be 0.7123 and the maximum value will be 0.887. In question 4A2, the manager would like to estimate the proportion of customers who like the new taste of drink in the next experiment. We should determine the sample size such that the error does not exceed 0.08 with at least 95% confidence. In this question, we should apply the standard errors for proportions, which is shown here. Let n be the sample size that error does not exceed 0.05 with at least 95% confidence. Because the sample size is changed, the values of p should not be the same as the p in the previous question. Therefore, we should assume this unknown sample size as conservative sample size. We can apply the general formula for a confidence intervals, which is shown here, where Q is 1 minus P equal to 0.2, and as we are finding 95% confidence interval, alpha over 2 will be 0.025 and Z equal to 1.96. So after finding in the T distribution table, we know that the minimum value is 0.7123 and the maximum value will be 0.8877.
Hello, my name is Liu Shan and response to mock 3 question 4.
The question 4B is about in evaluating the customer satisfaction level. A company would like to be 95% confident that the error is in estimating the population mean does not exceed 0.05. If the population standard deviation is 0.8, what is the sample size required? Let us assume the n to be the sample size which considered to be large. The information given that the standard deviation sigma is 0.8, and we can find the significant level alpha is 100% minus 95%, that is equal to 5%. Therefore, we can find the alpha over 2 is 0.025, and through the nominal distribution table, we can get the value z is 1.96, because the population mean no larger than 0.05. So after calculating, the n will no less than 983.4. The sample size should be the 984. Let's move to the question 4C. In a random sample of 500 clerical employees from a large company, 300 says they would like the company to adopt a flexible scheduling policy, which would permit employees to decide when and how much they would work. Construct a 90% confidence interval to estimate the population proportion of clerical employees favoring the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. According to the formula, firstly we need to find out the P hat, which is 300 divided by 500 equal to 3 over 5. And the Q hat will be 1 minus 3 over 5 equal to 2 over 5, since our target is 90% confidence interval. The alpha over 2 is 0.1 over 2 based on the normal distribution table. The z value is between 1.642 and 1.65. Thus, using 1.642 plus the square root of 3 over 5 plus 2 over 5 divided by 500. Therefore, we get the minimum value 0.5640 and the maximum value 0.6360.